Very nice venue. Thank you very much. Okay, so our next speaker is Tony Fawl from the Manchester Space Programme. Woo! And his talk is actually about the space programme. And so, for 1 million astronaut points, which can be redeemed later, how high do you have to be before you get into space? I think they all got one then. I think, I said it was too easy.
You said it was too easy.
There we go. So, big open space conference. Round of applause for Tony Fawl. Yay. Thank you, Tony.
Thank you. Hello, everybody. I'm going to give just a very brief talk about the Manchester Space Programme. It's basically when we started, what our objectives were, what we achieved, how we did it, how much fun we had doing it. There'll be a little video showing the stuff that we did, and then open for questions at the end there. Okay, so the Manchester Space Programme, what was it? We wanted to encourage access to space for members of the general public. It was primarily aimed at anybody who had this question in purple, which is members of the large government organisations or corporate and academic institutions seem to be the only people with access to space and near space research and expertise. I want to explore space and be part of something that my family and friends could join in. That was really the essential part of the group. That was what we were set up for. I'm not a space expert, I'm a project manager, and that's why I was the project manager of the programme. It was started off at Manchester Digital Laboratories by some very capable and technical people, but it was really run by members of the general public. So the projects, we had quite a few projects. I'll explain three of the main ones. The first one was the high altitude ballooning. It was told to us that you could, for just a few £100, get stuff up, throw stuff up, as Mark, who's a member of MSP, said you can throw stuff up into space or near space. And we were in disbelief. We thought it was all going to be academic, the group, but it's not. It's very practical. So we set off 5 launches, and we got into near space on at least 2 of those. Each mission took about 4 to 5 hours. They were tracked by open source and open resources. And the current altitude record that we got pictures and video of was 37,776 meters, or roughly 124,000 feet. At that level, as you can see the blackness of space in daylight, and it was very exciting. High altitude balloons can be tracked with an open source, an open access website and service called HabHub. You can see in the top here, we launched from Macclesfield. We recovered the payload in, on the Humber estuary, and we were able to track the balloon as it ascended, as the balloon popped, and as it descended, to a point where we were able to drive up and pick it up, which was pretty good because the equipment inside cost, a couple of £100 to do. I mean, we're not awash with money, we're members of the general public, so it was quite difficult. So to be able to do this meant that exploring near space was actually possible. With a group of people and access to a little bit of funding, anybody could do it near enough. The preparations were difficult. We had to do quite a bit of research. For instance, we used a latex balloon here, and you'll notice they're wearing gloves, because even a little bit of oil from your fingers on the balloon, when it got to altitude, would cause it to pop. Let me give you an example. This is approximately 1.5 to 2 meters wide, but by the time the balloon got to its apex, the highest point, it's 8.5 meters wide, as the size of a small house. And because, of course, there's so much air pressure on the balloon at the moment that as it goes up where there's less air pressure, the pressure inside forces the balloon to go much wider, to a point where it pops. We've got a picture of that. It looks amazing. Bits of latex flying around space. It was terrific. The balloon pops, and then it starts its descent back. I think this is the best picture we got of all of them. This was on the Doge 1 flight. And this is just a very brief video, there's no sound I'm afraid, of, I've cut down the 2-hour thing into like 2 minutes, so it's not. You can see we've got, these are members of the MSP, we're filling it up with helium at this point, and there are people holding it to keep it steady. We had a couple of unsuccessful launches where the wind was so bad that it just blew into telegraph wires. It took us a week to get the payload back, you know, so there were some failures as well. Damon, this guy nearly got his head knocked off. You'll see why in a second. This is the launch. The payload just missed his head. It was good. In fairness, it was designed so that if somebody got hit on the head by it, it wouldn't kill them. So it was polystyrene around it. You have to be considerate of these things. I'll explain why in a moment. But you see, it's going up very, very fast. We reached the cloud layer really in a few minutes. The biggest problem that we'd got was, as you can see, the camera, the rotation of the payload. And then we're above the cloud line, and then we start to see some of the really what were amazing pictures. To see the blackness of space during daylight was a major achievement for us. And you've got to remember, we are not space people, we're just people who are really interested in it. We're prepared to learn what it took to be able to do this, and found that actually it was a lot of fun and quite easy. It's not that hard to do this. If I can do it, seriously, really anybody can. Yeah, so unfortunately we're using a cheap GoPro knockoff from China, so the curvature goes a bit odd at the edges of the screen, but yeah, it was marvelous. At this point, just a bit higher than this, the balloon popped. We don't have a picture of that, unfortunately. I was looking through the collectors of the pictures to find it, and I couldn't find it in time. And then the descent from the apex down to the ground was fairly uninteresting. The landing was interesting, but yeah, just maybe spending too much time on this because I was just so proud of it. So yeah, at this point we're descending. It's spinning around quite a bit, so you can see.
Does it have a parachute?
Yes, you may remember seeing at the start. There's the payload where the camera was. There was this orange and green little very small parachute, but engineers in the group actually calculated the size of the parachute that was needed to bring the payload down safely. You can see it's very dodgy, and then bash, that's it, landing. And that was the parachute just at the end, you may have just seen it. So yeah, it was great fun. We had 5 of those. 2 of them were unsuccessful. We got some with tardigrades in, you know, those little tiny, and that we'd launched in high altitude wind. It was only a breeze on the ground, but it got trapped in the telegraph wires. We had to contact all sorts of people to try and get it down. And so the tardigrades only got 50 feet up instead of 50,000 feet. So, and there was another one where we landed in a top secret military installation. You can imagine going down. We were very frightened of going to receive. They were very good about it, but
with the Chinese branded camera.
Basically, yeah. And another one, a very frightened old lady. Where was it, Mark? I can't remember. We went down and she was petrified. She'd seen this thing. She was in her back garden gardening, and she'd seen this thing come down. She thought she was going to blow up or something. So, you know, it can be exciting, silly, and a bit scary. So, but we managed those. Other projects, that's the recovery. We were very pleased to get it, you can see. This is a bit of the latex balloon that was pulled down. That's the parachute. This is the payload, which had the transmitter in it and the camera.
Is that Harvey?
Pardon?
Is that Harvey?
That's Harvey, yes. Harvey, yes, he's a member of the group. This is Pete, who went on to, I think he works for the UK Space Agency now.
But that was the project for university students, wasn't it?
That was?
A project for university students.
This was for Manchester Space Programme, which was part at the time and based at Manchester Digital Laboratory. Yeah, we used to meet every Thursday and talk stuff like this, and then we actually managed to work out how to do it. And we did a few, like I said, and that was the project for high altitude ballooning. The other one, we thought, well, if if we can do something like this, what about making it accessible to children, for instance? So we dreamed up the idea of piconauts, which is a microscopic, tiny little 13-gram integrated circuit, tiny little solar panels, and very small wire aerial. And this would have its main objective of being having a foil party balloon, a third filled with helium. The little payload would be captured, and you could set it off yourself, and it would get up to about 20,000 feet. But at that level, at that altitude, we knew that it would just blow around the globe. Because it's an aluminium balloon, it's very strong. There's no rain or wind or anything there which is going to destroy it. And it would stay up there for a long time. And I think the record at the time was about 6 circumnavigations of the globe. Now, we worked out a way of being able to make these for about £100, between 50 and £100. So we thought it'd be great to be able to fabricate these and give them to schools. And my wife wrote a computer program so that you could track this via HabHub. It would tell you the coordinates. You could even press a button and it would show you the Google satellite view. So children would be able to get maybe not into space or near space, but pretty high up and at least understand the technology and so on available to it. We loved this. So unfortunately, it meant that we had to design one of these ourselves. And that's where we started to come against resource problems and technical expertise. But we still have the idea, we're still keen to do something like this, even if it's just for ourselves. I think lots of schools, and we did have school teachers involved in the group, would be interested in it. Also rocketry. We did have one of these, which we did speak at, or we had a stand at the UK Space Conference a few years ago, and we had this, and people were very excited by it. We weren't, frankly, because the amount of explosive that you've got to have in one of these just to be able to get it even a quarter of the way up into space is very scary indeed. So it was pretty much decided on the offset that we wouldn't be utilising this, which was donated to us at the time. A guy came back and took it away because he was appalled that we wouldn't use it. So we went for much more modest, smaller rockets, just really to get kids interested, see what it's like, and ourselves. We like the idea of putting a little explosive in the bottom of a re-engineered toilet roll. So it was quite good. And that was, you know, we put little electronics in to track them and things. That's quite good fun. We also spoke at various events, particularly astronomical societies. They're very keen on this, and we went on various excursions to things like the Manchester Observatory. We spoke at the UK Space Conference. That's Mark, who's here, and Harvey, of course, who some of you recognise. So very, very briefly, just to end, I want to talk about membership and composition. Anybody can set up their own space program and at least do what we did. You remember, most of this stuff that we did was 10 years ago. It's not that difficult. There is funding available for it. We got funding from the UK Space Agency, but also my company at the time, TalkTalk, they gave us a couple of £1,000 to develop the Piconaut project. There are various other organisations, Manchester organisations, which have funding available for people who are interested in doing community projects. Community projects are a big thing. You know, it's a good thing for people to be members of community projects, and people are willing to fund that. So things like the balloon, the helium, the electronics are purchasable, and you can get funding to do that, provided you could put together a group. Look for funding, it's out there, even in these times. Membership. Grockles like me aren't necessarily the sorts of people you're looking for. I am a project manager, so I could do admin and things like that. But you also need people with expertise. And I found it difficult. I'm speaking to a couple of guys in the audience here who are putting me right, giving me some pointers. But I found it difficult to find young, bright minds with a keen thirst for doing this stuff. I could find a lot of old fogies like me, but not that many of the younger people with the skills. University students are a good example, the skills to be able to do that. So that's one of the risks that your group will have. You do need technical expertise. And the biggest risk of all is making sure that the jobs that you've got for your community project, which is involved in space, are diversified so that not all the pressure is just on one or two people, which is very easy to do. Harvey, for instance, as you saw him, an awful lot of pressure was put on him because he had a lot of diverse expertise, and it was very unfair. He's still part of the group, fortunately, but it was very difficult. But then you've got pictures like this, which is pretty good. And most importantly, of course, have fun. And that's basically it. Any questions? Yes. Oh, you've got to wait for the microphone.
Sorry.
Caught you unaware there, didn't I? Quick, run.
Got her, she's on.
Yeah, so one of my sons, who's at Lancaster University at the minute studying mechatronics, he's interested in doing something like this. I think he wants to 3D print a drone that we can send up in space. Do you need any particular permit, or can you literally just release these devices?
No, you can't. You have to have a permit. But the British Aviation Authority will give you a permit. They will. You fill out a form. And you tell them what you're going to do. You explain to them how, using HabHub, you can calculate where you expect it to land, the part of space, and they'll say, yes, but not in this area or this area, because there's planes flying over, or this area or this area, but you're fine in Macclesfield, and you're fine over there, and you're fine in Blackpool or whatever, but not this point, this point, this, and they're very, very good and very approachable about it. So it is possible, yes. But you do need permission, definitely.
Because your flight path went right across the Manchester Airport
You'd
approach, didn't
think
it?
so, wouldn't you? Yeah. But I think it was that at that altitude, it didn't make any difference. Nothing travels more than 35, 40,000 feet anyway. So we were, I think we'd cleared it and they knew that.
And what about landing as well, when you mentioned the interesting incident with the top secret facility? And indeed the poor old lady that saw the thing.
Yeah, well,
Going down on the roof. It could land anywhere.
it could land
be in the
anywhere.
centre of Hull.
It could have been in the centre of Hull. It could have, we expected, it could have been in the Humber Estuary. It could have been in the North Sea. The thing about HabHub, as I mentioned a little earlier, you can predict to quite a degree of certainty, not exactly, but to a certain degree of certainty, whether you're going to land on land, for instance, or in the sea. And if you were going to land in the sea, you'd just postpone it for a couple of days till the wind changed. So you can calculate these
But
things.
I think from your perspective, landing the sea is a good thing. Sorry, a bad thing, sorry. But from like a public safety perspective, that's probably the best way.
Yeah, I see your point.
Yeah, so if it lands in the centre.
Somebody, I can't remember, it wasn't me, somebody mathematically calculated the likelihood of somebody getting hit on the head with one thing, and it was millions. It was really millions.
Worth doing.
It was, and we went to an extra extreme of making sure that it was fully foam covered, that it wasn't too heavy, and all sorts of other things. In fact, that square one, we thought that in the end we were a bit unsure about, so we made a round one. That would be better if it hit somebody. We were thinking things like a car. Yeah, very fast. But like I say, we did test it. We did test it, and it was so light that the force of it hitting somebody was not that bad. It wouldn't cause any injury. But yeah, you're right. We did have to test it. Right, I live on the 5th floor, and the number of times we dropped the thing, and then people were heading it back and all that sort of thing. Yeah, and higher. Yeah.
So, since I think you mentioned that you can see the darkness of space from more than 35,000 feet. So, are there any commercial aircraft or like airlines that you can fly where you can get the same experience? Maybe.
There are commercial astronaut things which you hear about in the news, but that's about all I know about it. And they're hundreds of thousands of pounds to be part of those. We don't have that budget, unfortunately. Otherwise, Mark would have definitely done it.
And is the Manchester space program still going on? Like, are you still sending balloons up?
Yes, we are. And some of us are still keen to develop these ideas and expand on them. It's all right sending a high altitude balloon, but what interesting experiments would people want to conduct at that height? It's not just a matter of getting good pictures. You know, do we want to put life and see what effect it have on life, that sort of thing? Do we want to send pictures dynamically to see what it's like as it flies? Those sorts of things. Some people are interested in the electronics behind that, setting up sensors and gluing those, if you like, or soldering those to the boards. So there are lots of things we could do. Personally, I like the Piconaut project.
So how do we get involved?
Just speak to me afterwards or contact the Manchester Space Programme. We still have a website, manchesterspaceprogramme.org.
Cool. Thanks.
Any other questions?
Do you know if there's a maximum altitude that a helium balloon can actually get to?
There is. Unfortunately, I don't know.
That's
no,
fine.
there is, because if you think about it,
You
otherwise
run
it
out of air at some point.
that's right.
Yeah.
And it would. I did know it. I just can't remember.
It's all right, no worries.
It's a lot higher, unfortunately, the 124,000. It's not like we nearly broke the British record. We're a long way off.
Yeah.
And we definitely didn't get anywhere near the 100 kilometres that you mentioned before about getting into space. We were totally in near space. But the air wasn't breathable. And like I say, we could see the blackness of space.
Yeah. For the nano project, have you heard of a company called PCBWay? If you can design the electronics, they build it for you.
Right.
I don't know if that's useful too. I can have a chat with you about it.
Yeah, that would be a good idea.
Yeah.
Because we looked at Shenzhen
Yeah.
as fabricating our stuff, but
Yeah.
we gave up.
And on projects that you're looking for, a number of years ago, Sheffield University built, you know, that one with the CDs on. That's what what is the atmosphere like at that altitude? What's floating around up there? So that's another interesting one, especially for universities and what have you.
Absolutely.
But yeah, excellent. Thank you.
Thank you.
Nobody
else?
I want to also say that Manchester Space Programme has kindly donated the rest of their budget to run this event today. So if we can please give them a round of applause.
Very worthwhile. Very worthwhile. We're very proud sponsors. Thank you.
Thank you very much.
So we're coming to our own conference block now. So if anybody has written